All right, these are your last 3 or 4 questions in the notes we didn't get through to today. Hope you are able to learn from this and we can discuss as needed on Monday. This first question says, write the first 4 terms and the general term of the power series for f of x right there, and we'll consider an interval of convergence. Hope here is that you notice that this over here is just the geometric series, and that right there is a manipulation of the geometric series. And so what I'm going to do is write these out, and then we'll try to put them together to find f of x. So 1 over 1 minus x is equal to 1 plus x squared plus x cubed. I'll do a few more of these, I think. X to the 4th, x to the 5th, x to the 6th, something like that. Plus plus x to the n. And then 1 over 1 plus x would just be 1 over 1 minus negative x with that substitution there. This would give me essentially the exact same series, just alternating instead of not. So we get this like so. And then I guess we could say this would be negative 1 to the n times x to the n. Okay, so then to get f of x, I just need to add these 2 series up. And I think what I'll do is I'll just kind of add vertically. So if I look at the first terms here and here, 1 plus 1 is 2. So that'll be my first term. Then when I look at the next terms, of course, we can see that that's not going to be the result. Positive x plus negative x is going to add out to be 0. So I'm not going to write that term. The next set, I'll just draw an arrow this time. X squared plus x squared would be 2x squared. Can you see that the x cubes would add out to be 0? The x to the 4ths, of course, don't. With those, we end up with plus 2x to the 4th. The x to the 5ths are going to add out. The x to the 6th won't. And hopefully at this point, we're starting to see a pretty distinguishable pattern. I'm out to my 4th term right here, so I have written the first 4 terms. We need to think about this, the general term now, so I'm going to put plus plus 2, and then if you notice all of your exponents are even, so it'd be 2x to the 2n. A little hard to see where that general term would come from here because depending on what n is, you're either going to get 0 or you're just going to get x to the n plus x to the n, but then how do the exponents work there? It's probably just better, easier to see the pattern here rather than try to mess with those nth terms. Then as far as an interval of convergence goes, I don't know, why don't I run a ratio test and just see what this looks like? This would be the limit as n goes towards infinity, and it would be 2x to the 2 times n plus 1 over 2x to the 2n. We want that to be less than 1. So limit is n goes towards infinity. So it would be, the 2's would obviously cancel out. Up here, this is really 2n plus 2. So I think we're going to get x squared in there again. So this is going to lead me to believe that my radius is 1 and my interval is that. Without testing the endpoints, though, let's check that out. I think we're going to get the same thing either way. So for x equals negative 1, we're going to get sigma. I'll put the 2 out here just to make it a little more clear. It'd be negative 1 to the 2n. That's just going to be 1 plus 1 plus 1, so that's going to diverge due to the nth term test. And for x equals positive 1, it's going to be 2 times sigma of 1 to the 2n. So this is going to diverge because it's basically just 1 plus 1 plus 1. So I think we'd end up with a final interval of convergence of that with open on both endpoints. Okay, hope that worked for you. If not, ask questions when we get to class on Monday. Let's look for the other ones that we haven't done yet. It looks like another one we didn't do was number 15. This one says show that. So anytime you see the word show that, that means we're going to really be proving something. Presupposing that it's already true, we're going to try to prove that it actually is true. So we're supposed to show that y equals f of x equals that power series is a solution to this differential equation right here. So notice some really important symbols like we looked at in class today, equal signs, right? So it's saying that y and f of x are equal to that power series. So that means I can replace that power series, or I can replace that y or that f of x with that power series or whatever piece of that power series that I need in order to get this done. So here's what I'm going to do. I see right here that I'm going to need y prime. And so I think maybe the first thing I'm going to do is think about the power series for y prime. So y prime would equal, the derivative of 1 would be 0. And so this would be negative 2x over 3 factorial plus 4x cubed over 5 factorial minus 6x to the 5th over 7 factorial. Obviously, I could do some simplifying right there, but maybe for the moment I'll leave it alone. Okay, so what I'm going to do now is I'm going to use that right here in place of y prime. So here's what that would look like. It would be x parentheses negative 2x over 3 factorial plus 4x cubed over 5 factorial minus 6x to the 5th over 7 factorial plus ... And then that is supposed to be plus y, and I know that y is just that power series up there, so that would be 1 minus x squared over 3 factorial, so on and so forth. So keep in mind here, this has asked us to prove that this power series is a solution, or this function for the power series is a solution to this differential equation. And so really all I have to do this is I have to show that using that will produce a true statement. Looks like kind of a mess right now. Let's see what happens if I clean this up a little bit. So over here I'm going to distribute the x across this power series. So that's going to give me negative 2x squared over 3 factorial plus 4x to the 4th over 5 factorial minus 6x to the 6th over 7 factorial. And I've still got this other piece over here. And hopefully I've got some like terms that I can combine and simplify this quite a bit. So let's see what happens here. So the first term I see here that I'm going to deal with is the 1. I don't have anything like it, so I'm just going to rearrange this in ascending order. So I've got the 1. Then I've got my x squareds. So if I look at this term here and this term here, I've got negative 2 and negative 1. If I add those up, I'm going to get negative 3. So that'll be negative 3x squared over 3 factorial. The next thing I see as I move up the degrees here would be 4th degree. So that would be this one right here and this one right here. So I've got 4 of them on the left. I've got 1 of them on the right. If I add those up, I'm going to get 5 of them. So that would be plus 5x to the 4th over 5 factorial. And lastly, I've got my 6th degree terms. If I add those up, I'm going to get minus 7x to the 6th over 7 factorial. This is still supposed to be equaling cosine of x. It is cleaned up quite a bit, but the last step here is maybe just to recognize that basically the front of the factorials is going to cancel off on all these. So, for example, on this first one, the 3 factorial is really 3 times 2 times 1. So this 3 would cancel with that 3, leaving me with x squared over 2, or it could be written as 2 factorial. Then over here on this 4th degree term, 5 factorial is really 5 times 4 times 3 times 2 times 1. So those 5s would cancel. This would leave me with plus x to the 4th over, I think you can recognize that that's 4 factorial. And something very similar happens on the end here. The 7 cancels with the front 7, leaving me with minus x to the 6th over 6 factorial, plus, I guess I forgot my plus dot 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 here. Put that in. So plus dot dot dot, cosine of x. And then the final step really is just a recognition. It's recognizing that the series, the power series on the left, is the same thing as cosine. So I could finally get to the end and say cosine of x equals cosine of x. Check. Or QED. I'm done. Okay, so again, at the start there, the instructions were to show that or prove, and so I think that maybe we have proven what they asked us to do. All right, moving on. I think we got a couple left. Okay, this one gives us a function f of x, and it gives us a power series for that function. And it goes on to say we're supposed to give the Maclaurin series for this other function, g of x, which is equal to x times f of x, and then we're supposed to recognize that g of x is some other function that we're supposed to know. Okay, so if g of x is equal to x times f of x, and f of x equals that power series, then what I can do is I can replace f of x with that power series. So it would be 1 plus x over 2 factorial plus x squared over 3 factorial plus x to the 3rd over 4 factorial plus dot dot dot. I'm not too worried about the nth term on this one because it doesn't say we got to do anything with it. I'm going to go ahead and distribute the x. So g of x equals x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial, so on and so forth. So far what we've done is we have found g of x essentially, but now we're supposed to express this in terms of a known function, something that this is equivalent to, that's not a power series. Like I've mentioned in class, the factorials are usually a pretty good hint about what we're looking at here. And as I look at these factorials, I essentially see 1 factorial, 2 factorial, 3 factorial, 4 factorial. And this should spur your memory here a little bit, hopefully, that that factorial pattern only goes with e to the x. But if I were just to say this, I think this would be wrong because e to the x does not start with x. The power series for the Maclaurin power series for e to the x starts with 1, and so that 1 is missing. And so I would say that this is perhaps just e to the x minus 1. That would essentially just peel that 1 off or cancel that 1 off the front, giving us the exact power series that we have right there. So I'd go with this for our answer on 16. All right, let's move on to the last one. Okay, so number 17, our last one, I think, says use the first 4 non-zero terms of the series for f of x equals that function right there to approximate the integral from 0 to 2 of sine of x over x. So it might be useful real quick to talk about why this function is presented as a piecewise function. If you think about this top piece is basically in force for negative infinity to infinity, except for just one spot, right, when x equals 0. And so what that means is that sine of x over x is going to be completely continuous everywhere except for x equals 0. And if you remember from, I guess we've maybe done this with L'Hopital's rule. We've done this, I'm trying to remember when we've done this before, but if you look at the limit as x approaches 0 for sine of x over x, you actually get 1. And so this other piece right here is basically the point 0, 1. And so what that does is that fills in that one little missing point from sine of x over x. What that essentially does is that makes f of x continuous for all values of x. Why that's important is we don't want to have an improper integral over here. We want to have a nice continuous integrand. And by looking at it from this perspective, I think we can be a little more comfortable with the continuity of the integrand. Therefore, we can do the integral. So here we go. Let's not get too hung up on that. Here's the main stuff. Here's the main thing we want to do here. We want to look at sine of x, power series for sine of x, which would be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And that's the first 4 terms right there. So what I'm going to do now is write the power series for sine of x over x. So that would be 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial minus x to the 6th over 7 factorial. So essentially what I've done there is just divided every term through by x. So now what I can do is put this back in as the integral from 0 to 2 of 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial minus x to the 6th over 7 factorial dx. So this is going to be our approximation for that original integral. All right, so next step is to find my antiderivative. So that would be x minus, it's going to be x cubed over 3 times 3 factorial plus x to the 5th over 5 times 5 factorial minus x to the 7th over 7 times 7 factorial, and then that whole expression is going to be evaluated from 0 to 2. Okay, so using then FTC1, I'm just going to plug in the 2 for x and the 0 for x. So that's going to give me 2 minus 2 cubed over 3 times 3 factorial plus 2 to the 5th over 5 times 5 factorial minus 2 to the 7th over 7 times 7 factorial. And maybe you notice that if you plug in a 0, since all those terms just have an x there in the numerator, plugging in a 0 is just going to yield 0. I have no idea what that's going to end up being, so I'm going to pause here and check out my calculator, and we'll figure out what this will end up being. All right, so you can see here I've done a few calculations with the calculator. I think it turned out okay. And this is approximately equal to, if you want to use the calculator to find the decimal here, 1.60526 approximately. There's some more decimals on there, of course. So then we could then say that the integral from 0 to 2 of sine of x over x is approximately equal to that. And as we've done before, we could actually quantify our error here, or bound our error, by considering what kind of a series we have. This is an alternating series, and so the maximum error would be less than or equal to the first neglected term. So if you wanted to calculate that out, I think I'll just put r sub 7. So my remainder based on the 7th degree, or my error based on the 7th degree, I think would be less than or equal to, I think that next term would be 2 to the 9th over 9 times 9 factorial, which is, I think, a pretty tiny number. Let's see here. So looking at the calculator, yeah, so that error is 1.5677 times 10 to the negative 4th. So, pretty tiny error there just after a few terms. It didn't say you had to do that, but I thought I'd throw that in there. Since it's a converging alternating series, the first neglected term, right, would be the bound for the error. Okay, so I think that is it. Hope that went well for you. I looked over the homework a few minutes ago, and I think that it's all, some of it might be challenging, but I think that it's all pretty doable for you. So do as much of that as you can this weekend, and come prepared with questions or just whatever thoughts you might have for Monday. So I hope you have a great weekend, and I'll see you in class on Monday.